Hello, my sweet and precious students. Welcome back. I had a special request for prime factorization, so we're going to do a lesson about that today. All right, we're going to start by first things first. Actually, before we jump into prime factorization, I want to make sure that you know your rules of divisibility. Rules of divisibility. There are more than what I'm going to talk about today, but these ones are super important. So our rules for divisibility. It's not spelling tutoring, it's math tutoring. Okay, rules of divisibility. We know something is divisible by 2 if it ends in an even number. Ends in an even number, and let me show you why. All right, had to get my multiplication chart for this. So if you look at 2, you'll see it ends 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. If it ends in one of those numbers, it's going to be divisible by 2. If you divide something by 2, cut it in half. Dividing by 2 is just cutting in half. And if you think of it like that, it makes it a little bit easier. Okay, number 3, we're going to come back to number 5. Here's how we know something is divisible by 5. If it ends in a 5, 0, 5, 0, 5, 0, bam, nice, 5 or a 0. So ends in 5 or a 0, 5 or 0. The other one you'll want to know is 10. If it ends ends in a 0, Okay. And so if you'll know if it's 10 if it ends in a 0. That's going to be kind of helpful with that 5 one. Okay, the 3s. The 3s are a little bit tricky, but I want to show you this lovely trick. If I ask you, hey, is 27 divisible by 2? Here's what you do. You take those 2 digits and you add them together. 2 plus 7, that equals 9. Does 3 go into 9? Sure heck it does. So 3 is going to go into 27. This also works for 9. Does 9 go into 9? It sure does. So it's going to go into 27. Here's a different one. 15. 1 plus 5 is going to give us 6. Does 3 go into 6? Absolutely. So 3 is going to go into 15. Does 9 go into 6? No, it does not. So 9 is not going to go into that, just 3. This is a really neat trick for being able to look at something and identify if a 3 is going to go into it. For example, if we have 57, okay, well that's 5 plus 7. That's going to give me 12. Does 3 go into 12? Yes, it does. So therefore, 3 is going to go into 57. If you get a really large number, you can actually technically keep breaking it down because 1 plus 2 is 3, and 3 goes into 3, so 3 is going to go into 57. Okay, so add up the digits. So this is if we can find a multiple of 3, or if something is divisible by 3, add up the digits. If a multiple of 3, then it is divisible by 3. All right, so these rules are going to be super important for when we're doing prime factorization. Now, the other thing we need to talk about are prime numbers. Prime numbers are things that can only be multiplied by itself in 1. Multiplied by itself and 1. 1, neither prime nor composite. I can't spell today. Composite just means it's built up of, it's made up of multiple things, right? So let's go through some of these. 2 is going to be prime. 3, that's going to be prime. Now 4 is going to be composite because 4 breaks down into 2 times 2. So if you can break a number down, it's considered composite. Now I'm going to list off all of our prime numbers, the ones that you really need to remember. We've got, so 1 is not prime, it's also not composite, it's a weird one. We've got 2, 3, 5, not 6, not 7, not 8, or I'm sorry, yes, 7. What am I thinking? Not 6, not 8. Not 9, because 3 times 3, not 10, 11. Okay, not 12, but 13. Not 14, not 15, not 16, 17, 18, 19. And then I think the next one is 23. Really, you only need to know up to like 13. Sometimes 17, but 13 is going to be your key here. This is all really important information because when we go to do prime factorization, we're breaking down our numbers into the most, into those base numbers. I call them base numbers, and I know that's not technically correct, but I like to make things weird. I don't know. All right, so prime factorization, how do we do it? We take a look at this number here and we see that, oh, this is definitely divisible by 2 because it ends in an even number. And I'm gonna be honest, there's probably other things that would be better for dividing this. It's okay, you're gonna get the same answer either way. So I'm gonna do 2, but what do I need to multiply 2 by to get 224? Remember I said dividing by 2 is really just cutting in half. And if I cut this in half, I would have 100, and then half of 20 is 10, and half of 4 is 2. So I'd have 112. Again, that's 100, 10, and 2. That sometimes works, sometimes doesn't. It's up to you. What I like to do is circle my 2. All right, 2, 3, 4. So if you see, I just added those up. 1, 2 is 2, plus 2 is 4. So 3 is not going to go into this, but I definitely know 2 will because, again, it's ending in an even number. So if we do that, it's going to be 2. And what do I need to multiply 2 by? Well, a half of 100 is 50. Half of 12 is 6. So that's going to give me 56. Okay, 56. Now, 56 can be broken down even further. And now I like that it's a more recognizable number because I look at that and I think, oh, right, that's going to be 7, which is prime, times 8. Now, 8 is not prime. It is going to be 4 times 2, which is prime. And then this guy is going to be 2 times 2. All right, so now we have all of our prime numbers. Here is how you write this. You want to start with your lowest base number, your lowest prime number. We have 2. I have 1, 2, 3, 4, 5 of those. So 2 to the 5th power times. All right, and I like to cross off as I go because otherwise I get confused. ADD kicks in. Times, and my only other number is 7. So 2 to the 5th times 7, that's going to give us 224. Let's just double check that I'm right because I've been known on these videos to make mistakes. So here's what I'm doing on my calculator. I'm doing 2 to the 5th. That little guy is called your caret. On your computer, it's generally above your 6 key. I don't know if that's the case for Apple, sorry. But that's your caret. And so your caret is putting something into the power like that. So 2 to the 5th, I'm going to hit enter, equals that garbage. And then I'm going to multiply that by 7. So times 7, I get 224. Whew, I did this right. All right, let's try another one. Look at this guy here, and I think, okay, it ends in an even number. So what I'm going to do is cut it in half. We're going to do 2, which is prime. Half of 100 is 50. Half of 8 is 4. So I get 54. 54. All right, I also know that that is divisible by 2. But also, if we add up 5 and 4, we get 9. So 5 plus 4, that's going to give me 9. And again, when you add up all those digits and they go into 9 and they create a number that is equal to 9, or a multiple of 9, that means 9 is going to go into it. So I can easily say, all right, well, 9 times 6. Awesome. Now those can be broken down further. This guy's going to be 3 and 3, and those are both prime, so I'm going to circle them. And this guy is going to be 2 and 3, and those are both prime, so ta-da, I can circle those guys. All right, again, what you want to do is write these in order. I have 1, 2 2's, so that is 2 to the 2nd power, times 1, 2, 3 3's, so 3 to the 3rd. 3 to the 3rd. All right, let's try another one here. 243. 243. All right, well, 2 is not going to work for this guy. So let's try our adding, right? If we do 4 plus 2 is 6, 7, 8, 9. It adds up to 9. So that means 9 is going to go into it. How many times? Oops, I was about to circle 9. Don't do that. That's not prime. 9 can break down to 3 and 3, which is prime. So I'll circle those. What do I need to multiply 9 by to get that? Heck if I know. We're going to do some side work. 2, 4, 3 divided by 9. Well, 9 can't go into 2, but it can go into 24 if we do that 2 times. 2 times 9 is 18. It can't go 3 times because that would be 27 and that's over. So now when I'm subtracting here, I go from 18, 2 more to get to 20. From 20 to 4, 20 to 24 is 4. So that's going to be a difference of 6. They've shown studies that if math teachers talk out loud as to what they're doing mentally, it really helps students. So you'll see me do that quite a bit. If it doesn't make sense, just do your traditional method. That's totally fine too. All right, when we subtract to find our remainder, remaining balance, we also have to bring down. 9 goes into 63 7 times. 7 times. So, all right, well, now what we know is 9 times 27 will give me 243. So, 9 times 27. All right, I'm going to break this guy down. 9 times 3, right? 3 is prime. So 9 times 3 will give me 27. Break this guy down, I get 3, 3, bam, bam. So 243, and I'm sorry about my writing here, I'm going to rewrite it like this. 243, that's really 3 to the 1, 2, 3, 4, 5, 3 to the 5th power. That is my answer. If you like your teacher, circle or box your answer because it's so much easier to find. And then that way, when they're grading it, they can make sure it's easy. Now, 87, I love this. When it ends in a 0, make your life easy. We know that it's going to be 16 times 10. Because remember, our rules of divisibility say if it ends in a 0, it's divisible by 10. So there we go, 16 and 10. Those are much more manageable numbers than 160. 16 is going to be 4 and 4, which is 2 and 2. Bam, bam, 2 and 2. And then this guy is going to be 2 and 5. All right, again, we're going to go in order. So 2, I have 1, 2, 3, 4, 5. 2 to the 5th times 5. Excellent. All right, stop the video. See if you can do this for 89 and 91, and then come on back. All right, so let's give this a shot. We've got 32. I know that's 2 and 16, right? 2 and 16. Yes, okay. I make mental math problems all the time, or mistakes all the time. So 16 we know is 4 and 4, which breaks down to, and I forgot to circle my 2. Geez. 2, 2, 2, 2. That is 2 to the 5th power. 2 to the 5th power. This guy, again, it's got a 0. Score 36 and 10. Now 10 I already know, 2 and 5 because we did it once before. 36, that is 6 and 6. Those can be broken down into 2 and 3, and 2 and 3. All right, so what I have here is 1, 2, 3, 3 2s, 2 to the 3rd. Let me cancel those out so I don't get in the way. Oh, and then 2 3s. Oops, that's supposed to be a times. 2, oh, I'm sorry if my face is in the way there. All right, 3, 2, because there's 2 3s, so 3 to the 2nd power, and then 5 times 5. Okay, so 2 things. One, we're going to talk about, so I want to talk about this 2 to the 5th. Here's how I remember this, and I'm going to say, but before we talk about that, I need to talk about the why we do that for our exponents. So if you take a look at these problems here, starting with number 99 here, that's a 9. I don't know, I can't write. What this means is not 5 times 2. This means 5 2 times. So this is 5 times 5 times 4. 5 times 5 times 4, and the 4 is just to the 1 power, so it's just 1. 5 times 5, we know that's 25, times 4, that's going to give me 100. Think of quarters, right? If you have 4 quarters, you have $1, and each quarter is worth 25 cents. So these exponents, you got to be real careful. A lot of kids make that mistake. They say, oh, hey, 4 squared is going to be 8. Absolutely not. It is 4 squared is going to be 16 because it's 4 times 4. So be very careful and diligent about that. Now, how does that go back to what I was just talking about? These guys right here, 2 to the 5th. It's a good idea for you to remember your 2's. So 2 to the 1, we know that's going to be 2. 2 to the 2nd is going to be 4 because 2 times 2 is 4. 2 to the 3rd is going to be 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. I bet you're noticing that each time it's doubling, right, from the previous one. So I can never remember which is which, like 2 to the 5th, what is that? But what I can remember is 2 to the 6th is 64 because they both have a 6 in them. So then I say, so when I saw this 32, I thought, oh, 2 to the 6th is 64. So if I cut that in half, that's going to give me 2 to the 5th. And so sure enough, we got that. So it's just a little trick to kind of, it's not necessary for this, but it's just something you may want to remember because these come up a whole bunch, especially 2 to the 3rd. That is 8. Drill that one into your head. You're going to need that a whole bunch. Okay, so let's talk a little bit more about these when we're talking about exponents, and then I'll go back to that prime factorization. So this guy right here is saying 0 one time. That's just going to be 0. That's all that is. Over here, this is saying 3 times 3 times 3 times 0 times 0. Well, anything times 0 is 0. So it doesn't matter what all this is. It's going to be 0. But I just want to show you 3 times 3 is 9, because a lot of people look at this and say, oh, it's 9. But no, it is times, and I'm going to say 0 times 0 is 0. So if I bring this guy down here, right, remember 9 times 3 is 27. So again, our answer is still 0, but I wanted you to see that because 3 to the third is 27. That's another good one to remember. 3 squared is 9, 3 to the third, 27. That one will come up a whole bunch, either now or in your next algebra class. Okay, so then I made a mess. Sorry, I lost my other. There it is. Okay, so let's try some more of these, guys. We got 4 to the 1 power. That's literally just 4. Yay, that's easy. 4 to the third is 4 times 4 times 4. All right. 4 times 4 we know is 16. Times that by 4. All right. 4, okay, so 16 times 4. We've got 6 times 4 is 24, so 4 and 2. 4 times 1 is 4, plus 2 more is 6. So 16 times 4 is going to be 64. Now remember my trick. I said 2 to the 6th power equals 64, right? You will not need to know this until the future, but I just want to show you this. We're going to take that 4 to the third, 4 to the third power. 4 to the third power is, or I'm sorry, 4 is really 2 to the second power, right? To the second, I hold up one finger. 2 to the second power. So this is really 2 to the third power. 2 squared to the third power. If I multiply these guys, that's one of our rules of exponents you'll be learning. I get 2 to the 6th. And sure enough, so 4 to the third equals 64. But so does 2 to the 6th. These are the same thing. 4 to the third, 2 to the 6th. Totally the same thing. Just wanted to show you that. All right, let's look at this guy. 3 times 3 times 3 times 1 times 1. Anything times 1 is itself. So we can just cancel that out. We don't need it because it's going to be itself. This guy is going to be 9, and I'm going to bring that down. So times 3. That's going to give me 27. 27. All right, so let's go back to some of those prime factorizations so you can see this. Let's try these guys right here. So if you're ready, you think you can do it, pause the video, come on back, and give it a shot. All right, 144. Now, my other piece of advice is, if you don't know your multiplication tables, that's okay. But what you should really know are your perfect squares. And your perfect squares are things like 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on and so forth. You're going to want to know those up to about 15. And on my multiplication chart here, and I love this one because it's a 20 by 20, and yeah, I got it at like Vector Stock or something. I Googled it. But you'll want to see that all of your perfect squares are, this is 2 times 2, 3 times 3, 4 times 4, 5. These are all very precious numbers in math, and you'll want to know those. If you do, you'll know that this is a perfect square. It's really 12 times 12. So I'm going to give myself some room here and stretch that out. So 12 times 12. Neither of those are prime, but we can do 3 and 4, and this is prime, and this is 2 and 2. Cool. Well, what if you say, instead of 3 and 4, I want to do 6 and 2? Totally fine. This is what it looks like. There's 2, that's prime, and 6, and that becomes 3 and 2. You'll notice on this side I have 3, 2, 2. On this side I have 3, 2, 2. It all breaks down. Does not matter what numbers you want to choose, as long as they multiply together to give you that original number. So we're going to do 2 to the 1, 2, 3, 4 power times 3 to the second power. And that will give me 144. All right, so 48. Again, there's multiple ways of doing this. We can do 6 times 8. We can do 2 times 12. Not 2 times 12. Let's try 4 times 12. That would be better. Or 3 times something. I don't even remember. 48 divided by 3. You'd think I'd know this by now. 16. We can do that. Let's do that since I apparently can't remember what 3 divided by 4 or 48 divided by 3 is. So 3 and 16. 3 is prime. 16 is 4 and 4 or 8 and 2. Doesn't matter. 4, 4. This is going to be 2, 2. Bam, 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 bam. So I get 2 to the 4th power, because there's 1, 2, 3, 4, times 3. Awesome. All right, last one, 216. Let's take this guy. I don't even know off the top of my head what that is. So I do know it's even, right, because it ends in an even number. So at the very least, I'm just going to cut it in half. So I get 2, and then 100 cut, or 200 cut in half is 100. 16 cut in half is 8, so 108. All right. Oh, wait, look at that. It's 1 plus 0 plus 8. That's 9. So I know 9 is going to go into this number. I just have to figure out how many times now. 9, 108. 9 goes into 10 one time without going over, with a remainder of 1. Bring down my 8. 9 goes into 18 2 times. So 9 times 12 will give me 108. Beautiful. Let's break these guys down. Those base numbers. I call them base numbers. I don't know why. 3 and 3. Beautiful. This is 3. That's prime. And this is 4. And that guy is going to be 2 and 2. Kablam. We've got this guy factored. We got 2 to the 1, 2, 3 power times 3 to the 1, 2, 3 power. All right. If you have any questions, please drop them below. Let me know. Otherwise, great job. And I look forward to seeing you next time.